Well, hi there, boys and girls. Today we're going to do some more U-Substitution, what I'm calling easy stuff for U-Substitution. And I'm going to do a trig example, and I'm going to do a couple more that are similar to what we did yesterday. And so we're going to start with doing antiderivatives for trig functions. And I'm going to tell you that the antiderivative of sine of u, du, is equal to negative cosine of u plus c. And of course, this du is very important. This has to be the inner derivative. Alright, so let's take a look at this problem here. The antiderivative of sine of x over 2 dx. If I'm going to use this formula, then that means that my u would have to be x over 2. So I'll let u equal x over 2. So the next thing we do is we take du dx. The derivative with respect to x is 1/2. Because you can think about that as 1/2 x. What do we want to solve this for? Well, we just want to solve it for dx because that's all I have left in the problem. So I'm going to get that 2 du is equal to dx just by cross multiplying. So this integral turns into the integral of sine of u times 2 du. So my answer from this formula will be, the 2 is going to come through here, and it's negative 2 cosine of u plus c. And then we back substitute our x over 2 in for u, and so we get negative 2 cosine of x over 2 plus c. And so that answer is B. So the u substitution also works with your trig identities. Okay, I want to do one that is something you're going to see tomorrow, and that's the integral of tangent squared x times secant squared x. Now this one you're going to have to think about which one of these functions is a derivative of the other one. So you're going to have to remember some derivatives. Now the derivative of secant is secant tangent, and the derivative of tangent is secant squared. So knowing that, this is probably going to be the inner derivative. So if you were going to work this problem, you would want to rewrite it like this. The integral of tangent of x squared times secant squared x. So what would you let u be? U would equal tangent x. What is du dx? Well, you'll have to remember what the derivative of tangent is. The derivative of tangent is secant squared. Secant squared. Well, we're erasing that. We're going to redo that one. There, that's better. Now we cross multiply and we get that du is equal to secant squared x dx. So all of this is simply the derivative of tangent. So we turn this into the integral of, well, this is all u, I'm sorry, this is u squared times du. So we do our antiderivative and we get u cubed over 3 plus c, and we back substitute, and this answer is tangent cubed x over 3 plus c. Alrighty, so let's do a couple more. You don't always have to do u substitution if you can recognize it in the problem. So I'm going to show you what I mean by this. Now, I've got the integral of 1 plus 2x to the 4th times 2 dx. In your head, you might think, well, all of this is u. This is exactly equal to the derivative of u. So this is a perfect inner derivative. So you really don't have to substitute if you have this situation. If you have a perfect inner derivative, just add 1 to the exponent and divide by that. So that's 1 plus 2x to the 5th over 5 plus c. If you go through all your u substitution, you'll get the same answer. Let's look at another one. What about the integral of square root of 9 minus x squared times negative 2x dx? Again, you don't have to go through all the u substitution. You can think about this as 9 minus x squared to the 1/2 power. and then times negative 2x dx. So if this is all your u, this is a perfect inner derivative. The derivative of this is negative 2x. So since that's the case, just add 1 to this exponent and divide by that. So we would get 9 minus x squared to the 3 halves divided by 3 halves plus c, which is the same thing as 2/3 9 minus x squared to the 3 halves plus c. So anyway, that's only if there's a perfect inner derivative. I still want to do another example because we just cannot see this enough. What if it's not perfect? For example, what if I have x over 1 minus x squared cubed? And we're going to integrate this dx. Now here we want to bring this 1 minus x squared back up to the top. So it's going to be 1 minus x squared to the negative 3. Now if you think about this as your u, x is not a perfect inner derivative, but it's close. X to the first is involved with the derivative of 1 minus x squared, but we're missing some constants. So I'm going to go through u substitution here, and I'm going to let u equal 1 minus x squared. So that means that du dx is equal to negative 2x. I've got a visitor real quick, so I'm just going to pause for just a second. All right, so we're back. Now what we have left to substitute for is x dx. So I'm going to solve this for x dx. So negative 1/2 du is equal to x dx. So this turns into the integral of u to the negative 3 times negative 1/2 du. And so now we add 1 to the exponent and divide by that. So it's u to the negative 2 divided by negative 2. We still have this negative 1/2 out here. And then plus c, which is going to turn into a positive 1/4 u to the negative 2 plus c, which is going to be, in our u, of course, up here, was 1 minus x squared. So this becomes 1/4 times 1 minus x squared to the negative 2 plus c. And then you'll probably see this written as 1 over 4 times 1 minus x squared plus c. Now I want to point out something that you can do if you don't want to go through all of this u substitution sometimes. This is something you can do if you don't have a perfect inner derivative but it's close. So I'm going to erase all this, so I hope that you wrote it down. So we're going to back up to all the way to the beginning. Alright, so what I have here is I've got an inner derivative, the x dx, that's pretty close. X dx is close to the derivative of 1 minus x squared. How far off is it? Well, the derivative of 1 minus x squared is negative 2x. So I really wish there had been a negative 2 here. So what you can do is you can put a negative 2 there, but you have to put a negative 1/2 out there, because you can't just come around and multiply something by negative 2. The only thing you can multiply things by is 1. And so notice negative 1/2 times negative 2, well, that is 1. So what I have created here is here's a u, and right here is a perfect inner derivative. So if you do that, then you can skip some of this u substitution stuff, and then you can just add 1 to this exponent and divide by that. So let's see what that looks like. The negative 1/2 has to come through, and the answer to all of this is 1 minus x squared to the negative 2 divided by negative 2, and we get, oh, don't forget a plus c, and we get positive 1/4 times 1 minus x squared to the negative 2, which is 1 over 4 times 1 minus x squared plus c. Not all of you are going to be able to do that. If that just confused the heck out of you, then don't worry about it. Just go through with all of your u substitutions. All right, well, I think that's good enough for now. Tomorrow you're going to practice U-substitution some more. It's a very important concept. You've got to get this part down, the easy stuff down, before we can go do some of the harder stuff. So I will see you guys tomorrow.